quadratic word problems that deal with area. So they've given us our question here, so we'll read through it quickly and then we'll pull out what's the important stuff. So Gabriel has a playground that's 8 meters by 10 meters. He wants to double the area of the playground by increasing all of its sides by the same amount. How much must he increase each side by? Okay, so we know that the measurements of the current playground are 8 by 10, and we know he wants to double the area. So that means we need to figure out the original area in order to double it. And then he also wants to increase all of the sides. Increase sides. They all got to be by the same amount, which is important to us. Okay, so I'm going to draw a diagram here. Our first little playground, say it looks like that. It's an 8 meter by 10 meter playground. Now what he wants to happen is he wants to increase or expand every single side, kind of went into the words there, by the exact same amount. So what that means, I'm going to move this all over. Can I do that? Oh, that's better. We want to increase every single side by the same amount. We don't know how much that is, so we call that value x. Okay. So this was the original width, and this was the original length. Okay. So the new width is going to be plus. That's not plus. I'm off today here. Plus x, and because we're doing all sides, we'll say he's going this way also plus another x. Okay. So the new width, I'm going to highlight it in blue, takes the old width's measurement, so we take that 8, and we add x to it, and we add x to it. So what that would look like is 8 plus x and x. Well, 1 square, we just write a coefficient of 2. 2x, okay? So that's our new width. That would be the expression to represent our new width. And our length, which will be the yellow part, is the exact same stuff. Just this side's being increased by x, and this side's being increased plus x. So we take 10 plus x plus x. So our new expression would be 10 plus 2x. Okay. Some other stuff that's important. We need to know the original area. Area of this is 10 by 8, which means the original area was 80 meters. And he said he wanted to double the area. So the new expression, this new area, the larger playground, is going to have an area of double 80. So we multiply by 2. It's 160 meters squared. Okay, so the new area. So first thing we want to do is build an area formula. So we're going to say a at x. So we're still writing it like a function notation. What we're saying is x is the variable in the formula. And area of a rectangular object is the length times the width. Okay, put them in brackets. Our expression for width is right here. So we'll put the expression here in blue. And the expression for length is right here. So we're going to replace both of those with the two expressions we got. So our new length expression is 10 plus 2x. And our new width expression is 8 plus 2x. Okay. And that is all equal to the area. Well, we have a new area also. Our new area, we had said, is 160 meters. So we're going to replace this area here with 160 meters. So the new area is 160 meters. So 160 is equal to this expression. Now we need to figure out what values of x we can use that will give us this new increase. In order to do this, we want to set this expression equal to 0. Okay? That way we can find, essentially, if we were to graph this type of equation, what the x-intercepts are. So we need to move 160 over to the other side of the equation. So when we do that, the left side will now equal 0. And the right side will be 10 plus 2x, 8 plus 2x, subtract 160. Now what we're going to do is we're going to turn this into, we're going to expand and simplify. We'll put it into a standard form, and then we're going to factor to find out what our x values are. Okay? So you guys have to remember FOIL or rainbow method, whatever your teachers call it there. Then you do the first terms by the first terms, and the second terms by the first and second terms of the other one. So, are you okay with what that is, FOIL? Okay, so 10 times 8 is going to give us 80. 10 times 2x is going to give us 20x. 2x times 8 is going to give us 16x. And 2x times 2x is going to give us 4x squared. And all of this is still subtract 160. So we collect our like terms. And I'm going to put this in the order of the largest variable power first. Okay, so 0 is equal to, move 4x squared to the front. Next two common values here are common terms of 20x and 16x, so it becomes plus 36x. Okay. And then finally, our constants are 80 subtract 160, so we go, when we put those together, you get negative 80 as the value. Okay. So now I have a standard form. If you recall, that's like a B, and a C term. Okay. So I might be able to factor this using some factor methods. I know for sure I'll be able to find it using quadratic formula. So instead of playing around with a bunch of factored methods, actually I can probably find a really nice one. Maybe I should do both? Okay, let's try both. If I was to factor this, the first thing I would do is common factor 4 out. Okay, so I would take 4 out of each of those, so 4 becomes the common factor. And then we're left with x squared plus 9x minus 20. Okay, and actually this one's going to work out really nice. Or is it? Oh no, maybe not. I'm thinking 4 and 5. No, that's not going to work. Okay, so that's not going to work, but I can put this into a quadratic formula, or I can put the original in. So let's say I tried my factor methods, they didn't work out. I'm going to take the original one and I'm going to put it into the quadratic formula because I'm probably going to get some decimal values going through this. So a quadratic formula is x is equal to negative b plus or minus the square root. Put our division sign there while we're at it. Of b squared minus 4 times a, there's going to be an a here, times c, and all of that is divided by 2a. Okay? So as long as I know what my a, b, and c value are, this is really just following BEDMAS. We plug stuff in and find out where our x values are. So x is equal to negative 36, that was our b, plus or minus 36 squared minus 4 times our a value is 4, our c value is negative 80. This is okay, not too fast. And then all of that is over 2 times, again, our a value is 4. Okay. And I'll just color them in so you can see that the values are coming from that standard form. Okay. Here's our a value, and here is our c value. So now that we have that, we kind of go through the motions of this. We can probably do all of this in one step. What are we going to get here? Negative 4 times 80, or negative 80, will give us positive 320 times 4, 0, 8. So we're going to be
2,576.
Is that plus 36 squared?
Yeah.
Oh, perfect. You've done everything for us. Great. So we're going to find the square root of, so plus and minus
2,576.
Great. So much easier. And then on the bottom will be divided by 8. So
That's not a root.
Sorry?
Doesn't have the root of anything.
Well, it'll have a root. It'll be a decimal value.
Yeah.
So depending on how your teacher wants this answered, will they want the? And we should really think of it. We should really think of this in terms of
radicals.
Yeah, if they want it as a radical. But let's say I'm actually Gabriel in this question, and I actually want to expand this.
That's nice.
How do I go and figure that out if I'm going to like Home Depot to buy this stuff? I don't go and ask the guy for 5 plus radical 3 stuff. It doesn't make any sense, right? So your teacher might want it as a radical, but in terms of practicality, it makes sense to have an actual decimal value here. So we can definitely turn this into a radical, but let's actually get a decimal value because I think that'll be better for us. So at this point, we can kind of split our equation, right? We're going to get 2x values. X is equal to negative 36 plus the root of 2,576 over 8, and x is equal to negative 36 minus the root of 2,576 over 8. Okay, so we'll find out what those two values are. You want to do the one on the left, and I'll do the one on the right. So speed the time here. So root 2,576. So I need that to be a negative. And then minus 36.
I got 1.844.
Great. 1.844?
Yeah.
1.844. And I got, on our calculator here,
You got negative.
I got negative 10.8 roughly.
So x is equal to.
So in terms of measuring, it's impossible to go back negative 8, right? So if we went down 10, that literally means my width, because it's only 8 to start with, would be a negative value. So I'm in some other dimension, and this one would be 0.3. So that doesn't make any logical sense. So we go with the answer of that's a positive value, because in practicality we're obviously expanding the size. So 1.844 meters is the expansion on every single side. So that's the expansion. What would the new dimensions mean? Because our old dimensions were 8 and 10, we got to do 8 plus 1.844 twice, right? Because we're doing it on each side. And same idea down here. We have to do 10 plus 1.844 times 2, whatever that is. So our new expansion, 1.844 times 2. So we have to expand the entire width by 3.688, which means our new width, we added to our old answer, is 11.688. So our new width is 11 point, I already forgot.
668.
668? All right.
Yeah.
I have no working memory at this point. And this one, I think we're adding it by 3 something. What did we say? 3688, so this would be 13,688 when I add it all together. Perfect. So those are our new dimensions. We over-exaggerated this build here on this side. Okay, but those are our new dimensions of the playground. So there's a lot to do in this question. We have to put it into a standard form, then we have to factor it, then we take that answer, figure out which one's logical, plug it back into the original to see what our new dimensions will be. So there's a lot of work in this type of question.